Hi, you are welcome. Today we'll discuss one reaction called a directed ortho metalation. This is also called a DOM. The general reaction is that with an aryl substrate, which will have a group is called a DMG, which when reacts with aryl lithium or alkyl lithium, it will give a ortholithiated product. This is called the directed orthometalation. That means the lithiation will happens ortho to this DMG. DMG is abbreviated form, which is direct metallation group. If you see the mechanism is that with the heteroatom in DMG reacts with the alkyl lithium through CIPE effect, that is complex induced proximity effect, which then after removal of RH give this ortholithiated product. The reaction is very important in organic synthesis, as the ortholithiated product can easily gives different substituted product with suitable electrophiles. So one important thing is that the DMG must contain one heteroatom to operate this CPIE. DMG groups generally are like this: SO2NR2, OCONR2, and this all will have one unshaped pair of electron in an atom. Now we'll come to example. If you see the examples, the first one, this is when treated with secondary butyl lithium, it will give the ortholithiated product, that is this CON82, and which on treated with a electrophilic reagent, that is CS3I, and it will give a substituted product, and the final product will be this. In here the reaction goes through SN2, that is substitution nucleophilic unimolecular. If we come to the second example, it is also the same. The first ortholithiated product will be found, and then the reaction is with DMF. DMF is dimethyl formamide. So this is a suitable reagent for a CHO group to substitute. For a CHO group to substitute, and then we'll come to the reaction 3. When this react with secondary butyl lithium, will give the ortholithiated product, and when it is warm to room temperature, then this lithium will attack to this carbonyl group, and via an addition elimination reaction, the final product will be formed. Then the next example, here 2 equivalent of butyl lithium is required, as first this proton is quite acidic, so it will be abstracted by 1 equivalent, and the second equivalent will abstract this proton. Then PH2CO will give this product, which on cyclization give the final product. Now another thing is that aromatic ring, which if the aromatic ring have an heteroatom, then this ring will also gives the similar type of product, like furan and thiophene gives the similar type of product. But in case of pyrrole, the 1 equivalent and butyl lithium gives the lithium salt of pyrrole. One thing is important here is that the hydrogen lithium exchange is generally faster than halogen lithium exchange in some reaction. If in a substrate both halogen and hydrogen are having both halogen and hydrogen, then the hydrogen lithium exchange will take place rapidly than the halogen lithium exchange. If we see the example 1, this is a pyridine substituted with a phenyl group and a halogen, which when treated with tertiary butyl lithium gives the ortholithiated product of this aryl benzene, that is the phenyl, due to this heteroatomic effect, due to this heteroatom. But here the chlorine is not substituted with the lithium, because this hydrogen lithium exchange, which is much faster than the halogen lithium exchange, so the corresponding product will be formed. If we take the pyridine substituted pyridine, then also the chlorine and hydrogen, between this chlorine and hydrogen, the hydrogen gets substituted with lithium, but the chlorine remains intact and the corresponding product is formed. Another thing here important is, if we take a benzene with a halogen is generally bromine and iodine if as a substituent, then with alkyl lithium it gives the lithiated the halogen substituted product. Now another thing is that the reaction with tri-isopropyl silyl indole. With n-triisopropyl silyl indole, this with treated with tertiary butyl lithium gives the 3 substituted product. This may be because due to the presence of vacant d orbital of silicon, this nitrogen atom go delocalization to this silicon, nitrogen cell lone pair electrons, and that's why it's not available for or directed orthometalation. Another thing, if this triisopropyl silyl group is replaced by methyl group, then the directed ortho effect is observed, which came in GATE-2022, which in this substrate is treated with secondary butyl lithium, then ZnCl2. So as this is heteroatom having lone pair of electron, here DOM will operate, and here the lithium substituted product will be formed. Then reaction with ZnCl2 gives the corresponding ZnCl salt, and which when treated with this substituted pyridine give a coupling reaction. This is called Negishi coupling, and so the product will be this. For reference, you can follow the modern method of organic synthesis by Carruthers, advanced organic chemistry by March, and Wikipedia. So guys, if you have any doubt regarding this video, please let me know in comment box.